All right, page 7 in chapter 6. Find a z-value of a given area. Sketch the area. So we've been going z to p, percentile probability percentage area, z to p. Now we're going from p back to z, okay? So I always draw first. We're talking about a standard normal distribution. 0 is there with a z. Okay, find the z-value of a given area to the left of the z-score. So find the z-score that corresponds to the cumulative area of 0.3260 and its left. Okay, hint that the 0, so let me just draw this on here. From here over is 0.5. Okay, so if we're talking specifically a left tail, then 0.3's got to be a little farther over to the left. Okay, so let me try that again. For a left-tailed example, if it's only 0.3260, then it's got to be somewhere over here and to the left is your area. Okay, your probability of a data point being over there. So what we're looking for is what z-value that corresponds to. Okay, so you're going to have to use the tables. I'm going to think about it. This is in the negative zone, right? It's on the negative side of the z-scale. So I'm going to the negative table. And I am going to go in the center and look for 0.3260. So let's go over there to the negative table. Let me erase some other stuff that's been on here. Okay, and I'm going to go to the center here. So I'm looking in the center. Hang on, let me get rid of the rest of this stuff. Think about it. It's to the left of 0, so it's at least a 1, I would think. But look in the numbers in the center of the sheet here. 0.32. 0.3, this is 0.0, 0.1, 0.2, 0.3, 0 is down here. Let's see, I'm looking along. There's 0.03, I need 0.32, 0.3192, 3264, and 3228, so right here would be 0.3260 is what I'm looking for. When you're in the middle, you want to go to the closest one. This is only 4 away. That one's a lot farther away. So right here is my closest one. This one here, if you follow that out, that's 0.4, and if you go up, that one's 0.05. So let me go back over here. So there was a 0.328 here. That was under 0.06. And over here there was a 0.3264. That was over or under 0.05. This was all across from negative 0.4. Okay, so you want to use the closest one. So this is going to be at negative 0.45. Okay, that's kind of jammed in there. Let me write that down. I don't need the 0 in front. It's fine to write it in there. So z equals negative 0.45. That's what to the area to the left would be 0.3260. Okay? All right, what if it says something like P5? P5 stands for data to the left, okay, or 5% data to the left. 5% is a little tiny amount. This was 50%. This is 5%. So down here, we're still in the left examples, okay? So down here is an area of 0.05, right? We want to know what this z-score is. Clearly, it's negative, okay? So I'm looking for 0.05 in the negative chart. Let's go back over here. 0.05, there's 01, 03, there's an 05. We're going to go back right here. 0.05 falls between these two. Okay, sorry, I didn't mean to cross them out. Right here where that's actually pointing is your 0.05. Okay, when it's exactly in the middle, you want to go up. Okay, so this one's going to be negative 1.65. So let me go back over here. So 0.5 as a P equals a, so here, let me write this a better way. So you can write this like P of Z to less than point, what was it? It was negative 1.65 equals 0.05. So this turned out to be negative 0.65. Oh, 1.65, sorry. 1.65. Reading my own notes here. 0.165. All right, so let's try that again. All right, this one is 95% of the data is to the left. 95% of the data is to the left. From 0 to the left is 0.5. So 95's got to be up here somewhere, and then all of this is 0.95. All right, so if you look up 0.95 in the center there, you're going to find a 0.9505, and you're going to find a 0.9495. So it's exactly in the center. This is 0.05. You want to use that, and right here is 1.6, positive 1.6. So this is 1.65. Think about that. Did we expect that? If this is 0.05 and the rest of it's 0.95, we could have just gone 1 minus 0.05, and that would have given us the 0.95. So we would have known that it's the exact same, only without the negative on the upside. Okay? All right, what if it goes to the right? So if you have what's the Z value? If 10%, that's very little, goes to the right. So just this little bit here is 0.1075. All right, want to know this score. Clearly it's going to be positive. You look up, the problem is if I look up the 0.015, I'm not going to be on the positive side. So there's two ways you could do this. You could look up 1.075, and you're going to be, let's go over there, you're going to be in the positive table. In the negative table, 1 point, okay, let's look for 1 point. Sorry, 1.075. 1, 0, here's 0, 1075, right there. That's a negative, but clearly our drawing was positive. So you can either look it up on the negative and just record it as a positive. So this is 0, 1, 2, 3, 4. So this is negative 1.24. That's my answer, as long as I take the negative off. Or I subtract it from 1. I take 1 minus 0.1075, and I get 0.8925. So I go to the positive table for 0.8925, and there's my positive 1.2 and 0.04. So 1.24. So subtract it from 1, get the proper, because remember we have to read this to the left. So here, let me go back here for a second. So that means this area right here is 0.8925. Okay, this is 1.24. All right, so if you look up this, you're going to get negative 1.24. Just don't put the negative. Or subtract it from 1 and get the other number and look that up in the positive. Okay? That's the problem with all the tables reading to the left. All right, this one has an 88% to the right. 88% to the right. So remember, 5 to the right, 0.5 to the right is from half over. So 88% to the right would be all of this, approximately, to get P of 0.88. Okay, so again, you're going to read this one. So, and we're in the negative table, right? So you can do 1 minus 0.88 is going to give you 0.12. So if you look up 1.00, 1200, you're going to have 190, and you're going to have 1210. You want to go with the larger one. This one is under 0.08 and negative 1.1. So this answer is negative 1.18. Or you can go to the positive table, look up 0.88, and you'll get positive 1.18, and just add a negative in front to make it make sense. Okay? All right, and then one more page, we're going to do a between, right in the middle here is 95%, okay? So 95% in the middle, 95% in the middle, think about that. 1 minus 95 is 0.05, divided by 2 is 0.025. 0.025 here, 0.025 here. Okay, so if I'm looking for this one, I want to use 0.0250 and look that up. Okay, and that's under, remember that's going to be negative 1.96, 1.9 and then 6 the other way. So this is going to come out to negative 1.96, which means this is a positive 1.96. Okay, I do it that way. Some people take like from here over and get the positive number. So this would be 0.95 plus 0.025, right? Get that number and then look that up on the positive table and you'll get that one. All right. I like to just subtract it and get that one. So let's do that again. Zero's here, so 75% would be a lot tighter. All right, I do 1 minus 75, that's going to give you 0.25 divided by 2, it's going to be 125. So right here is 125, and I'm looking for this z value here in the negative table, and 0.1251 is the closest, 51 is the closest to 1250. So that comes out to negative 0.11 and 0.05. So this is going to be negative 1.15. That means this one's going to be positive 1.15. So you can write it like that or separate them with a comma. Okay? All right, last one. We want to do a little more bringing it all together in this problem here. All right, California police officer scores in the training tests are normally distributed. They are normally distributed. Okay, their scores are normally distributed. So they're going to fit in this here. Okay, and it says their mean is 50 and their standard deviation is 10. So plus or minus the standard deviations give us our scale on our x. On our x, giving us our standard deviations, right? All right, the agency will only hire applicants in the top 10%. Top 10%, I have absolutely no idea where that's going to fall in the standard deviations, okay? It says, don't forget it's in the 90th percentile. You know what? I have absolutely no idea where that is right at the moment. So that scale, don't be mad at me, the scale is not going to be helpful because this problem is starting with an area and I have right this moment, I have no idea where that is. Okay, so I'm just going to take a guess and say the top 10% is there. Okay, so that means this top 10% is here. That means this is the rest of the 90% of the people. Okay, so I need to find this z-score from this percentage. Okay, so the if I'm looking up 0.9 in the positive, in the center of the positive table, I'm going to find 0.8997 is the closest one. That's under 0.08, and this way is 1.2. So this right here is going to come out to 1.28 on the z-scale. Okay? But I need a test score. So I need to convert my z-score to a test score. So remember this formula we used before to go back the other way. So the mu was 50 and the z is 1.28 and the standard deviation was 10. So if I put that in there, it will follow my orders of operations. I'm going to get 62.8. Okay, so that's 62.8 on my x values. So the lowest score that you can earn and still be eligible to be hired by the agency, I'm going to go with, I put applicants must score above a 62.8. So maybe so this is going to be, remember the scores are equal to or greater than in this case, so that would be the lowest you can get and still be in there. Okay?